independent components, dependent component, independent variable, dependent variable, orthogonal, non-orthogonal component. Sometimes things look simple, but it is not the way it is actually. I mean, like uh, we have variable and we never bother that it is independent, it is dependent, or whatever it is. Okay, so like uh, 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 I have one variable called x, and there is a function over x, fx. Now, suppose that y equal to fx. So, x is independent variable, y is dependent upon x through function x, through function fx. So, independent variable has no dependency on any other variable. Okay, so in any domain, if there are so many variables, if they tend to change, but x won't change, that is independent variable. Y equal to function over x, y equal to fx. If that is true, then y is dependent upon x through function f. If x changes, then y changes. X is not dependent upon y, but y is dependent upon x. So, independent variable, dependent variable. These are two things. Now, suppose that there are two independent variables, x and y. There is a function over x and y, fxy. If that is true, then z equal to fxy. Z is a dependent variable upon two independent variables x and y through function f. So x and y go inside the machine, that is f, and it comes that there comes out as a new value called z. So z is dependent upon x and y, but x and y, they are independent. If that is true, if x and y are independent variable, then if there is change in any variable, x won't change. If there is any variable change in any variable, y won't change. If that is true, then if x is changing, then y won't change. If y is changing, then x won't change. These are independent variables. But whereas z, that is function over x and y, would change if either or both of the x or y changes. So this is dependent variable. Okay. So this is independent and dependent variable. What is orthogonal variable? If two variables are independent to each other, this proves that they don't have shadow of one variable over other. Okay, there is a sun coming from the light coming from this side. So to avoid the sun falling, I have put this. Okay, so there is a shadow. Okay, I don't know, it cannot be seen, but there is a shadow coming from the object. Okay, so if one variable shadow is not falling on another variable, okay, then I think we can. Okay, so there is object and this is my hand. So there is a shadow. If I take out, there is a full light on my hand. I believe it should be visible. And if I take this, then there is shadow. Okay. So if one variable, if one variable shadow is not falling on other variable, two variables are independent to each other. Now, in kind of angular world, okay, where things changes through angle, okay, our axial world, x-axis, y-axis, or I vector, j vector, k vector. where each are orthogonal to each other. So if I say that two variables are orthogonal to each other, means they are at 90 degree to each other in angular world. If they are at 90 degree to each other in the angular world, then they are orthogonal to each other, like x-axis and y-axis. They are orthogonal to each other, like x-axis, z-axis, z-axis, y-axis, x, y, z-axis. All three axes are orthogonal to each other. This proves that if any of them changes, then other two won't change. All are independent to each other. If all are independent to each other, they tend to make 90 degree in the angular plane or axial plane. So this is orthogonal, non-orthogonal, independent, dependent. Okay, so independent variable, dependent variable, orthogonal variable. So all independent variable tend to be orthogonal to each other. One modification in one arena won't make change in other domain. Let's take example. There is a function f with three input variables u, v, and w. So function exists on three independent variables. I'm sorry, means function exists on three variable u, v, and w. So I can say z equal to f u, v, and w. U comma v comma w f u comma v comma w. Then I can say that this is a kind of a function over u, v, w, z equal. Now, unfortunately, there is another function w equal to 2 into u into v. W equal to 2 into u into v. Z equal to function over u, v, w. This proves that the function, that is z, z is dependent upon u, v, and w, whereas w equal to 2 into u into v, w is dependent upon u and v. So only two variables are independent, that is u and v, whereas w is dependent upon u and v, whereas function is dependent upon z is dependent upon u, v, and w. So these are, so u and v would be orthogonal to each other, whereas w would lie on u, v plane. So orthogonal components, they make a plane. So w equal to 2 into u into v means w would lie on uv plane. F would lie on uvw plane. So this is orthogonal, independent, dependent, non-orthogonal value. Okay, how they are kind of important. I believe that we'll talk. So how they are represented. Okay, how everything, if we see the programming from C onwards, there is no kind of object class object representation in C, but there is a structure. You cannot live without the structure. So if we see class object concept, then we have the attributes a class contains. Those are its components. Those are variables. Okay. So if there is a class A and inside that there are pockets of variables. So there is a class called A and it has variable called alpha, beta, gamma. Their class has three features in machine learning terms. So class has three features or vector has three components. All are same. Class, vector, all are same. So a class has three features, alpha, beta, gamma. Now class is nothing but function over alpha, beta, and gamma. Function over independent. Oh, I'm sorry. I'm not saying that alpha, beta, gamma are independent variables, but function over three variables, alpha, beta, and gamma. That is the class. Class is also a function. So function over alpha, beta, and gamma. So set of value that alpha, beta, and gamma contains different set of values are different states of the class. The class has many states. All states are cohesive. That's why it's a class. If they are not cohesive, then with same set of three alpha, beta, gamma, it's a different class. That's what machine learning is. Even though features set of features are same, but class differs because they are not cohesive. Altogether, the set of the value what these attributes contain, those set of the value, that cohesion is different. Segregation is there. So the class is different. Now we have kind of a class which has attributes, and these attributes, this variable can be orthogonal to each other, can be independent if you are lucky. Okay. So like now I say that there is a class called child. Okay. So there is a class called child. Now child has many attributes: age, weight, knowledge, how much knowledgeable he is, age, weight, okay, and he has weight, he has age, okay, knowledge and height, age, height, weight, and knowledge. Now, if we see closely, then height, weight, and knowledge, height, weight, and knowledge are independent to each other. Irrespective of weight and knowledge, someone can have a height, any height. Irrespective of height and knowledge, someone can have any weight. Irrespective of weight and height, someone can have any knowledge. Whereas age is dependent upon height, weight, and knowledge. If he is more knowledgeable, then certain he would have spent time and he has more age. Okay. If he has more height, certain would have taken time. If he has more weight, then certain it would have taken time. So age is kind of dependent upon weight, height, and knowledge, whereas these three are independent to each other. Now that the class has four variables, class can have only three variables also: weight, height, and knowledge. So class has three independent variables, or class has four variables where three are independent, and internally one variable, that is age, is dependent upon these three. So this is class contains three independent variables. Nice if class contains all variables independent to each other. That we will see. Okay. Now I have a vector. I have tons of vectors. I have millions of vectors. Okay. One in this direction, one in this direction, one in this direction, one in this, one in this direction, one in this direction, one in this direction. I have millions of vectors. Can we see that there are only three vectors that are orthogonal to each other? I vector, j vector, and k vector. That's it. Out of million and billions of vectors, only three vectors are orthogonal to each other. So all vectors, so orthogonal vectors, they carry full information. Orthogonal vector, they carry full information. There is a vector like this and there is a vector like this, then they don't carry full information because they are not orthogonal to each other. Okay, but as we make it orthogonal to each other, then now they carry full information what these two vectors can maximum they can contain. Okay, like if I have like this, then if it is like, if these two edges are vertical to each other, then it is a rectangle, and anyone knows that rectangle is the maximum area that two sides can make. Okay, now consider that vector. What is your equation of the vector? The equation of the vector is 2i plus 3j plus 4k. I mean, I don't want I, j, and k. Three are itself a vector. I, j, and k. Three are itself a vector. What is equation of your vector? Like I, j, and k, I know. 2i, 3j plus 4k. Means vector is a class which has three attributes: I, j, and k, and in three orthogonal components, in three independent variables, million and billions of arrays can come, a vector can come. This is the importance of independent variable. Three independent variable, billions of vectors. Can you think? Okay. What is the color? Okay. So, what is the color? So, color is this. Okay. What is the color? Color is this. What is the color? Color is this. I mean, there can be millions of colors like this. What is the color? Color is like this. Okay. What is the color? Then color is like this. What is the color? Color is like this. Because how many colors? Millions, billions of colors. Okay. Can you make it short? Short, 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 short. There are only three colors. Billions of colors can be represented in only three colors. Each set of three colors is so a class called color has only three components: red, green, and blue. These are orthogonal to each other. If red changes, then no impact on green and blue. If blue changes, no impact and on red and green. Similarly, if green changes. Okay. Now, rather than having a class with so many colors attribute, we need only three color attribute. It saves space. If green has 8 bit, red has 8 bit, and blue has 8 bit, then in 24 bit you can have as many 2 to the power 24 colors. Otherwise, you keep 2 to the power 24 memory spaces. Okay, it saves memory. So orthogonal components, they carry equal number of information what you can have without orthogonal component. Okay, like if I have n number of features in machine learning. Okay, dimensionality reduction. I had brought this topic earlier. Dimensionality. How I can find same information with, like, there is a vector like this, then there is a vector like this, there is a vector like this, there is a vector, there are so many vectors in this plane. But to have the maximum information, I need only two vectors, x-axis and y-axis. That's it. Then it comes to rectangle. Anyway, in the same plane, you have 50 vectors. Maximum information it would contain is rectangle one. Because if you have vector in this direction, and another vector is in this direction, then rectangle will be smaller one. Okay, so from here it grows, comes maximum, and then it becomes, so maximum is smaller one only. So the we can say that independent variables are variables which keeps maximum information with minimum number of variables. If you reduce the variable keeping the information maximum, then that will lead to independent variable. So nice. Okay, so this is kind of a concept. Like I have a data integer. Okay, so there is a class which has data. Okay, what is its three independent variables: id, type, and value. Any data, it has id, it has a type and value. Id means what is the memory location where it is stored. Type means how it is aligned there, and the value. If we understand the orthogonal component nicely, we can have architecture of computer in minimum money and minimum space. This is the kind of charm. Whatever we are talking, it is not available in any book. You can search anywhere. All videos what we are making, all are research based, all are thoughtful, and all are new. Okay, you can take it as a challenge or as kind of whatever. You search anywhere, these informations are not available anywhere. All are new. Okay. So so we are in a phase to filing disclosure with each video. Whatever video you are making, one disclosure per video. Okay, now a society can have two independent components, male and female. So in a society, we can count how many males are there and how many females are there. Okay, a class realizing interfaces, those can be independent variables. Amazing. These are research-based uh, inventions. So if a class realizing interface I, J, K. I mean, it may not be possible to give I, J, K. So interface I1, I2, I3, I4, I5. Then I1, I2, I3, I4, I5 should be independent to each other. If that is like that, then your class contains maximum information with the minimum space, minimum time. So I1, I2, I3, I4, like printer, we are keep giving example as printer. So printer class is realizing print interface, staple interface, and fax interface. If someone gives for printout, it prints it, fax it, and staple it. If that is the case, then there are three orthogonal interfaces. Fax communication, that is faxing, will come under, and then binding, under which stapling would come under, and printing. So if printer class realizing print, staple, print, okay, print, communicate, and binding, then all three interfaces are independent to each other. Then class, printer class, contains three orthogonal interfaces, maximum information. Okay, so independent class. Then why we don't declare a class where all the variables are independent to each other? You can do. Finding independent variable is tends to impossible. Can you think that there are so many colors, infinite color? How someone came to know that it is red, green, and blue? How many years or decades or centuries it would have taken to find out that colors are nothing but RGB? So it takes time. If you are kind of time, if you are able to give the time, then you can find a class where all the components are independent. It's a challenge. But if you are, so I would say that give time and try to restrict minimize the number of components. Keep minimizing it, keep minimizing it, keep minimizing it, keeping the information same. That's how dimensionality reduction is. Ein vectors. Okay, ein vector comes into the picture where you try to get orthogonal component, nothing more than that. But there can be many algorithms dependent upon the scenario to find the orthogonal component. Finding orthogonal component is highly challenging. It looks simple that okay, now I have orthogonal components, but it is very difficult to find, almost impossible. So you can give time and keep the brain vector like that. So what is kind of why orthogonal component? So we talk the orthogonal component carry maximum information. Okay, so if this has width, okay, this has length and width, then area wise 2D direction, it has maximum information. If I have another vector like this, then it will be a cuboid. So if there are three independent components, the maximum, or if I have a cuboid, inside the cuboid, there can be many vectors, but all the information can be contained only in three vectors, I, J, and K. If that is true, then I, J, and K are independent variables. If I remove K, then information would reduce to 2D. So height information is gone. That we don't want. So volume is gone. It came to area. So any one if we take it out, so it is standing upon, okay. So it's like it is standing upon three. Okay, so it is standing upon three legs. Okay, so that is a power of independent. So independent component, they are the end result. If I keep minimizing the a number of components, keeping the information same. When it reaches to the end, those are independent components. Like if I go back, keep going back, you can see the wall. Beyond that, I cannot go. So I consider I am dependent upon the wall. So wall is independent. Like that, keep going, keep going, keep going. You will come to a situation where you will stand upon something. Okay. Beyond that, there is nothing. If that is the case, then it is independent. So independent components are kind of, we can say that they are pillars, pillars of any design. So now you know that how to design a software. So when you design a software, the biggest challenge is to find the independent component. If you find the independence, think that now if someone would have thought that how to represent a vector means energy and with direction and magnitude, only three components are required: I, j, and k. That's it. And anything can be represented through independent component. What is the color of this? Okay, black. Someone can say, but I would say 0, 0, 0. Red 0, green 0, blue 0 is black. What is color of anything means that it looks. What is the color of this? I would say 100. Red is one, normalized one. Red is one, other are zero. What is the color of anything that is yellowish? I would say 110. Okay, only in three components. What is the value of a vector? 2i plus 3j plus 4k. So any class can be represented through its independent variable, not required that we give name or something like that. It's so nice it is. Means I can say what is the color? I can say 1.0.0 like IP address. Okay. What is the equation of this vector 2.3.4? So 2.3, 2, 3, 4 are feature or attribute of a vector class where all three attributes are independent to each other. Okay. Now in a family, what is this family? This family is 2.3, means two males and three females. Okay. So now idea is that if you find independent component, then you can have your equation like that. So if I say there is a red, there is a green, and there is a red, green, and blue. If they come together, then whatever we get is the color. So we can just say that it is zero point 0.5, zero point 0.3, and zero point 0.2. Means red component is zero point 0.5, green is zero point 0.3, and blue is zero point 0.2. That's it. No need to say color. Just zero point 0.5, comma, zero point 0.3, comma, zero point 0.2. Okay. So this is kind of the world of independent component. Find means sometimes things look like a story, but in reality, it is very big. Okay. I mean, finding independent component is not the big thing; it is everything. If you are able to find independent component, then you can describe, you can represent your items through kind of independent components. Okay. Now we'll see that how it takes part if how we multiply independent component. Now it's easy, right? Color, color is same as vector, means they are individual. Now machine learning classes are same as vector because they have also have features. Society, male and female, there is also a vector. So everything is a kind of a vector. Calculus, okay, x-axis, y-axis. Okay, what is variation of any plane along x-axis? What is variation of, I mean, what is variation of a graph? What is variation of equation graph along x-axis? What is variation? That is called partial. Everything is of one independent component. Okay, if I have independent component y-axis independent upon j-axis, then if I have a 3D graph, then how much rate of change we see along independent component I, along independent component j, along independent of component k, then we can visualize the rate of change. We can find local maxima, local minima, okay, discontinuity. We can find that it is differentiable at this point or not. It is continuous function or not. Everything. You get the independent component, you got everything. If you did not get all the independent components, certainly you have not got everything. So calculus works. So slowly we'll see multiplying, adding, and deriving, and then calculus design principles. They are also something that is kind of dependent, that is based upon independence of the variables. Okay, many things. So knowing the independence in variable and then knowing the function over it, you are over.